This time, let's challenge a crazy physics problem. The problem reads, there are 3 cylinders with the same mass and radius on the ground. The coefficient of friction between cylinders are μ1, and the coefficient of friction between cylinders and ground is μ2. Try to find the minimum value of μ1 and μ2 in order to reach systematic equilibrium. Let's start with information that we can gather from the problem. At first, by looking at the graph, we realize that the triangle formed by the centers of cross-sections is equilateral triangle, which is the triangle right here. The second information is systematic equilibrium, which means that for each cylinder, F net equals 0, and net torque also equals to 0. With the help of our friend free body diagram, let's write down some equations. The free body diagram on the left is for the cylinder on the top. And because of symmetry, we only need to draw one free body diagram for the 2 cylinders at the bottom, which is the free body diagram on the right. If you watched our first video, which is find problem number 1, you probably can recall that we can solve problems by dividing vectors into different directions. For the first cylinder on the top, let's see, we have 2 normal forces from the 2 bottom cylinders, and also we have gravity, and also 2 friction from the 2 cylinders. So if F net equals 0, then F net in any direction equals 0 too. For example, F net in vertical direction equals 0. So let's write down all the forces in vertical direction. We have gravity, mg, which is downward. We have n1 times cosine theta, which is vertical upward, and n2 times cosine theta. And here theta equals 30 degrees. And 2 friction, which is F1 times sine theta, which is also upward, and F2 sine theta, which is upward also. And because of symmetry, N1 equals N2, and F1 equals F2. So our final equation will be 2 times F1 sine 30 degrees, because theta equals 30, plus N1 cosine 30 degrees, minus mg, which is gravity. This whole equation equals to 0, because F net in vertical direction is 0. So, great, we get our first equation here. Now let's analyze the free body diagram on the right. In vertical direction, we have mg, gravity, we have n2, upward, and we have n1 times cosine theta, as well as f1 times sine theta. Here, theta equals to 30 degrees. So let's write our equation, which is n1 cosine theta plus f1 sine theta plus gravity minus n2 equals 0, and theta equals 30 degrees. In horizontal direction, we have f2 to the left and f1 cosine theta to the left and n1 sine theta to the right, and that's it. Theta equals 30 degrees too. So in horizontal direction, we have n1 sine 30 degrees minus f1 cosine 30 degrees minus f2 equals 0, which is our third equation today. So now let's analyze net torque, which is also equals to 0. In counterclockwise direction, we have F1 times R. And in clockwise direction, we have F2 times R. And that's all the torques on the graph. So F1R minus F2R equals 0. So F1 equals F2. That's our final equation here. So I do a little bit algebra and plug in numbers. These are the 4 equations we got so far. We have 4 variables and 4 equations, so that's nice. First variable N1, and then N2, F1, and F2. N1 is the normal force between cylinders, which equals to mg over 2. And N2 equals to the normal force between the cylinder and the ground, which equals to 3 over 2 times mg. And F1 and F2, they're the same, so they equals to mg over 2 times 2 plus square root of 3. Because F1 is smaller or equal to mu1 times N1, and F2 is smaller or equal to mu2 times N2. Therefore, mu1 is greater or equal to F1 over N1, which is 1 over 2 plus square root of 3. Mu2 is greater or equal to F2 over N2, which is 1 over 3 times 2 plus square root of 3. These two numbers are our answers here. Thank you for watching.